May 25, 1953, 20 minutes past 8 in the morning. Frenchman Flat, Nevada test site. A battery of soldiers from Fort Sill, Oklahoma, stands beside the largest cannon the United States Army has ever built for war. 85 feet of steel on 2 sets of wheels, towed into position by a pair of tractors because no single vehicle can move it alone. They call it Atomic Annie. In 4 months, it will be 9 years since the design team was told to build a gun that could fire a nuclear weapon. And in the next few minutes, they are about to find out, for the first and only time, whether that is actually possible. 7 miles downrange, 3,200 soldiers and observers wait in open trenches, part of a much larger field exercise built around this single shot. More than 20,000 troops maneuvering across the desert that week to rehearse what an army would actually do on a battlefield where both sides had nuclear artillery. Among the men in the forward trenches, under 3 miles from the point below where the shell is meant to detonate, is a young soldier named Charles Lambert. He has a helmet, he has fatigues. That is the entire list of protective equipment issued to him that morning. The instructions from the loudspeakers were simple. Don't stand up, don't look toward the flash, or it may blind you. Somewhere behind him, in a much safer position, stand the chairman of the Joint Chiefs of Staff and the Secretary of Defense, here in person to watch a single artillery shell. The crew loads the shell into the breech. They close it, they insert the primer. Then, on doctrine drilled into every artillery crew since the First World War, they do the one thing that makes this morning different from every other test at this site. They run. Not toward the target, away from their own gun, into the slit trenches, because in the next few seconds, this crew's biggest fear is not the shell 7 miles away. It's the barrel 4 feet in front of them. Hold that thought because it's the whole story, not the size of the gun, not the size of the bang, the fear inside that trench. Men who had helped build this weapon, standing behind it, not entirely sure it would let go of what was inside it correctly. To understand why a battery of United States artillerymen could load a nuclear weapon into a cannon and not be completely certain what would happen when they pulled the lanyard, you have to go back to a much smaller number than 85 feet. You have to go back to 11 inches. Every nuclear weapon built up to that point used one of 2 ways to make a chain reaction start. The first is implosion. Pack the fissile core in a sphere, surround it with precisely shaped explosive lenses, detonate them all within microseconds of each other, and the shock wave crushes the material into a denser, critical shape from every side at once. This is elegant, efficient, and used almost every fissile material design fielded by 1953. It is also mechanically roughly the size and shape of a beach ball wired to 2,000 pounds of high explosive. It does not fit down an 11-inch gun barrel, and even if you could shrink it that small, the asymmetric shock of being fired, one enormous kick from the propellant, hundreds of rotations per minute from the rifling that stabilizes the shell in flight, would crush that perfect sphere unevenly before it ever reached the target. A design built to be squeezed with total precision cannot survive being fired out of a gun. So the engineers at Picatinny Arsenal went back to the other method, the oldest, crudest one. Gun type: take a ring of highly enriched uranium, take a smaller plug of the same material shaped to fit inside it, and fire the plug into the ring hard enough and fast enough that the combined mass goes critical. It's the same principle used in the bomb dropped on Hiroshima 8 years earlier. A design so straightforward, so mechanically forgiving, that it was the one and only weapon in history never physically test-fired before it was used in war. Gun type was crude. Gun type was wasteful of material. But gun type was rugged enough that it might survive being fired a second time out of an actual gun at forces the Hiroshima weapon was never built to withstand. Because that's what an artillery shell demands, that a bomb drop from an aircraft never has to survive. Setback force from the propellant charge, over 10,000 times the pull of gravity, trying to crush every component toward the base of the shell in a fraction of a second. Spin from the rifling grooves, hundreds of revolutions per minute, trying to fling the fissile components apart by centrifugal force before they were ever supposed to move. Build the mechanism too delicate, and the gun itself destroys the weapon before it leaves the barrel. Build it too rugged, and there's no room left inside an 11-inch shell for the uranium that has to be there. Somewhere between those two failures sat a design called the W9, 11 inches across, 4.5 feet long, 850 pounds, carrying roughly 110 pounds of highly enriched uranium in a ring and a bullet that were never, not once, fired together before that Monday morning in the Nevada desert. That is the detail underneath the whole story. Not that America built an enormous gun. Anyone with enough steel can build an enormous gun. The achievement in the gamble was building a nuclear device small enough to fit inside a shell, rugged enough to survive being fired like one, and precise enough to still detonate exactly the way its designers intended once it got where it was going. Nobody had proven any of that could be done together in one object. There was no way to test it quietly first. You cannot fire a shell part way. The only test available was the real one, with a live crew standing behind a live gun in front of the two most senior defense officials in the country. Win the story back 4 years to 1949 to understand why anyone built the gun at all before they'd solved the shell. The Soviet Union had just detonated its first atomic bomb years ahead of American intelligence estimates, and Washington wanted a nuclear weapon the Army could use on a battlefield, not just something the Air Force dropped from 30,000 feet. That distinction mattered more in Washington than it might sound. Since 1947, nuclear weapons had belonged almost entirely to the Air Force, carried by long-range bombers under the control of the Strategic Air Command. The Army had tanks, artillery, and infantry, none of it nuclear, all of it, in the era's thinking, at risk of becoming obsolete if a war in Europe turned nuclear, and the only way to fight it was from the air. A gun the Army itself owned and fired, on a battlefield the Army itself controlled, was as much about the Army's future relevance as it was about any specific tactical need. Picatinny Arsenal handed the job to an engineer named Robert Schwartz, who looked at existing artillery and found nothing that could plausibly be adapted. So instead, he looked at a captured German railway gun from the Second World War, the Krupp K5, and used its proportions as the starting point to design something new. A 280mm howitzer, scaled up from an existing 240mm design, built specifically around a shell wide enough that a nuclear device might someday fit inside it. The gun came first. The bomb that would fit it came after, on a much tighter deadline and a much harder problem. By October of 1952, the Army had gotten far enough to show 3 prototype guns to the public at Aberdeen Proving Ground in Maryland, and to fire them with ordinary high-explosive shells, nothing nuclear, just enough to prove that 85 feet of steel could survive its own recoil and put a round on target. That much, the engineers already knew worked. What they still did not know, what nobody on Earth knew, was whether the much smaller and far stranger object riding inside a nuclear shell could survive the exact same violence. By January of 1953, 4 months before anyone had actually confirmed that second half of the physics, the Army was confident enough, or needed to look confident enough, that a prototype M65 rode down Pennsylvania Avenue in Dwight Eisenhower's inaugural parade, towed past the reviewing stand behind a trio of elephants, in front of the new president and a crowd of spectators who had no idea they were looking at a weapon that had never fired a live round of anything, let alone a nuclear one. It was, at that moment, entirely possible that the whole concept didn't work. The parade happened anyway, because a nuclear-capable cannon rolling past the White House was worth more to Washington as a photograph than as a tested weapon. The proof would have to come later, in the desert, in front of a much smaller and much more nervous audience. Which brings the story back to Frenchman Flat, to the crew from the 867th Field Artillery Battalion standing at that gun on the morning of May 25th. Before the real round, they fired a handful of conventional spotting rounds to register the gun on its aim point, 7 miles out at a stretch of empty desert nicknamed Air Zero. Then came the shell that mattered. Breech closed, primer set, crew running for the trenches, because whatever the engineers in New Jersey had calculated on paper about setback force and rifling spin, nobody standing in that desert had watched this exact shell survive being fired before. And if the mechanism failed in the wrong way, the last place you wanted to be was next to the gun. At 8:30, the battery commander gave the order, Flame and smoke tore out of the 85-foot barrel with a crack that rolled across the whole basin, and for a handful of seconds there was nothing to see at all. Just a shell in flight, invisible, somewhere over 7 miles of empty desert, carrying a piece of physics nobody had ever fired this way before. Then, 524 feet above the desert floor, 19 seconds after it left the barrel, it detonated with the force of 15,000 tons of TNT. In the forward trenches, less than 3 miles from the point below the blast, Charles Lambert did exactly what he'd been told, and still felt the light come through his closed eyelids and his own hands pressed over his face, bright enough to erase color and shape for a moment, before the sound and the heat arrived a beat behind it, and the fireball climbed and rolled over into the shape every camera crew on the ridge had come to film. No injuries, no malfunction. The uranium ring and the uranium bullet, fired down an 11-inch barrel at forces the Hiroshima weapon had never been built to survive, had done exactly what the engineers on paper said they should, in front of the men who'd bet 9 years and a live crew on that piece of paper being right. More than 100 reporters had been brought out for this one shot, watching from a ridge 10 miles back, and within hours the story was everywhere. More than 20 separate news releases, front pages worldwide, 79 members of Congress among the official witnesses. The line every outlet reached for was the same one a congressman on the scene used that afternoon. The bomb dropped on Hiroshima in 1945 had been so large it needed a 4-engine bomber to carry it. What had just flown 7 miles over the Nevada desert was 11 inches across. Nobody in the press pool that day was thinking about tractors and turning radius. They were thinking about the number 11 next to the number that ended a war 8 years earlier, and what it meant that the distance between those two numbers had just collapsed to nothing. That's the kind of story this channel keeps finding. One small detail an entire program lives or dies by. Subscribe, there's another one already loaded. It was the only nuclear artillery shell the United States ever fired in its entire live-fire testing program. Not the only one built for the M65. Production shells for the gun continued for years after, but the only one anyone ever actually pulled a lanyard on, in front of witnesses, to prove it would work. Every atomic cannon that followed it into service in Europe and Korea over the next decade carried a weapon nobody serving alongside it had ever personally seen fired. Moving that gun at all took 22 men, a crew of 5 to 7 to actually operate it, and the rest to handle the 2 tractors, the armored ammunition carrier, and everything else that had to travel with it. Unlimbering it for action took 12 minutes if the crew was fast. Folding it back up for the road took 15 more. On the move, the whole assembly needed a paved or packed road at least 28 feet wide just to make a right-angle turn, which in practice meant Atomic Annie could not follow a battle wherever a battle happened to go. It needed the battle to come to a road built for something this size. Its maximum range, on the rare occasions it fired conventional ammunition rather than the one nuclear round it was built for, was about 20 miles. On the day that mattered at Frenchman Flat, the target sat at 7. And here is where the story turns, because success on May 25th did not mean the weapon had a future. It meant something closer to the opposite. The hardest problem the whole M65 program had solved, proving that a nuclear device could survive being fired out of an artillery gun, was never really about the size of the gun at all. It was about proving that a warhead could be miniaturized enough and made rugged enough to fit inside conventional artillery ordnance. And the moment American physicists had confidence in that principle, they immediately stopped needing an 85-foot, 150-ton, 2-tractor cannon to prove it. Within a few years, nuclear shells were being developed for guns the Army already owned by the thousands. A warhead called the W-48 that fit a standard 155mm howitzer, a warhead called the W-33 for the 203mm gun already deployed across every armored division in Europe. Rocket-delivered nuclear warheads were coming too, small enough for a single soldier to carry on a jeep. Atomic Annie had spent 9 years in one live nuclear shell, proving a concept that made Atomic Annie herself unnecessary. Only 20 of the M65 cannons were ever built. Somewhere between 10 and 16 were actually deployed, mostly to Europe by 1957, alongside batteries already receiving those smaller, far more mobile nuclear-capable guns. The math that had justified the M65 in 1949, that a nuclear artillery shell needed a gun this enormous to fire it, had been true for exactly as long as it took the physicists to solve the miniaturization problem the M65 itself was built to test. After that, the giant gun wasn't a weapon anymore. It was a monument to the problem it had just finished solving. It stayed in service anyway, for a decade after its one live shot, hauled around Europe by tractor crews who trained on a nuclear-capable weapon that, as far as any of them knew, might never fire the round it carried, because the round it carried had only ever been fired once, by a different crew, in a different country, 7 years before some of them enlisted. Prestige kept it in the inventory long after logic would have retired it. The Army finally withdrew the last M65 in 1963, 10 years, almost to the month, after the only proof anyone ever had that the thing actually worked. Charles Lambert went home from Frenchman Flat with a memory almost nobody else his age would ever have, the light coming through his own closed eyelids and hands, and no way in 1953 to know whether standing in that trench would cost him anything later. He was one of roughly 400,000 American servicemen present at atmospheric nuclear tests between 1946 and 1962, a generation the country would spend decades afterward arguing over how to compensate, and in some cases still is. What's left of that one shot is mostly photographs and 7 surviving guns. Most of the 20 M65s built were scrapped decades ago. The handful that remain stand today at places like the Army Field Artillery Museum at Fort Sill, Aberdeen Proving Ground in Maryland, and the National Museum of Nuclear Science and History in Albuquerque, muzzles pointed at nothing, having fired exactly one live nuclear round between all 20 of them combined. The gun preserved at Fort Sill is, by the Army's own record, the actual weapon that fired the Grable shot, which means the crew's hometown base ended up owning both the men and the gun that made the only shot in the program's history. The number that made the M65 possible, 11 inches, the width of a shell that had to carry a nuclear weapon and survive being shot out of a barrel to prove it could be done at all, turned out to be the same number that made it obsolete. Once the Army knew 11 inches was enough, it stopped needing 85 feet to prove it. There was no way to prove any of it without doing it for real, in front of witnesses, with everything riding on those first few seconds. That is also in a completely different machine, 13 years later, exactly what put a test pilot into an uncontrollable tumble that America would eventually watch over and over on television. That story is next on Tech and Flow.